Alright, students, today we are going to do the second chapter, the second lecture for the chapter lines and angles. So first we will see what is linear pair of angles. So students, let's say I draw a line segment AB, right? Now on this line segment, I draw a ray, right? Let's say this is the ray I draw on this line segment. So the angles hence formed, this is the first angle formed and this is the second angle formed. These angles are known as linear pair of angles. Why it's known as linear? The reason is it's on a line segment, or simply you can say it's on a line. If the endpoints are not there, it becomes a line. So a ray on a line, has two angles formed, and these two angles, angle 1 and angle 2, are linear pair of angles. So what are these angles? In this case, the linear pair of angles are angle 1 and angle 2. Alright students, what are vertically opposite angles? So students, just see, let's say I draw a line segment and I draw another line segment. Alright. Now I see four angles being formed. Four angles being formed. What are these angles? Now this is angle 1 and this is opposite to this angle is angle 2. This is one pair of angles. These are known as vertically opposite angles and they are equal. Angle 1 is equal to angle 2. Similarly, students, we have angle 3 and angle 4. These are also equal. Angle 3 is equal to angle 4. Angle 1 is equal to angle 2. Angle 3 is equal to angle 4. These two pairs of angles are vertically opposite angles and they are equal. Then come students, what is intersecting lines and non-intersecting lines and what is the distance between two parallel lines? So students, let's draw a line. Let's say this is a line. This is line L, and let's say this is line M. These are two lines. This is line L, let's say, and this is line M. So these two lines are intersecting on a point. Let me name that point as O. So very interesting things that these two lines are intersecting only at one point. Only at one point. Had they been curves, they might have intersected at 2 points. Let's say this is one curve L and this is the second curve M. You see, they are intersecting at 1, 2, 3, 4 points. These are two curves. But because it's a straight line, two straight lines, intersecting lines can intersect only at one point, and here we have named that point as O. Now students, what are non-intersecting lines? So let me see. Non-intersecting lines, students, they would never intersect. So this is one line. Let's say this line is L, and this is other line. So this is line M, right? Let me name these lines. This is line L and this is line M. So these two lines are non-intersecting. These are non-intersecting. Students, they will never intersect. There is no common point of intersection, and hence we can also see that the perpendicular distance between these lines is always same. The perpendicular distance between the lines is always same, and this perpendicular distance can be referred to as distance between two parallel lines. Once again, L and M are non-intersecting lines. If two lines are non-intersecting, means now you see this line is extending towards infinity from both the sides, and at no point they intersect. This means line L and M are non-intersecting. In other words, you can say line L is parallel to line M. Okay. If you see that the parallel lines never intersect and they also have a fixed distance. That distance never changes between them. That fixed distance is the distance between two parallel lines. Worth mentioning here is the intersecting lines. Interestingly, you can see these are non-parallel lines. Why? Because there is no fixed distance between these lines. You see, here the distance is more, the distance is decreasing. Here the distance between two lines becomes 0, and the distance is further increasing, and finally it becomes infinity. Students, here one more interesting point. Normally students don't understand what is the distance between a point and a line or a line segment. Okay, see students, let me draw a line. Let's say this is line L and I'm having another point P. Now, how many distances are possible between line L and P? They are infinite distances. Where are those distances? From point P, this is also one distance. From point P, this is also distance. This is also distance. And you see all these distances are different in the length. And here you keep going. The line is extending till infinity. There is no end point. So distances will also extend. Hence I said between a point and a line, total number of distances are actually infinity. But in geometry, we normally do numericals that what is the distance between a point and a line. You know what is that distance, students? That distance is distance PQ, which is the perpendicular drawn from a point P on that line. And students, it is interestingly the shortest possible distance between the point P and line L or any other line. Very, very important point. The distance between a point and a line doesn't exist. They are infinite distances. Which distance you are talking about? But when particularly we say distance between a point and a line in our geometry books or in our textbooks, they are talking about a particular distance that is the shortest possible distance between that point and the line, and that is the perpendicular distance. Remember that. Let's go next, students. A lot of things to be learned today. All right. Now, students, he says, Axiom 6.1. If a ray stands on a line, I hope students you do remember that what is a ray? A ray is basically what? It has one fixed point and the other point is not fixed. This is going towards infinity, right? This is a ray. And if I extend this also point till infinity, if I extend this point also till infinity, it becomes a line. If I extend this point also till infinity, it becomes a line. Otherwise, these two are rays. Alright, guys. Now, it says if a ray stands on a line, so we have a line. I'm sorry, I must go without the arrow. So this is a line, students, right? Let's say this line is L or maybe AB, then if you name it AB, it should be a line segment, but people instead of again and again saying line segment, they end up saying line only. Okay, doesn't matter. So you know that line has infinite length, but the line segment has finite length. It's a part of the line, small part of line. Now, if a ray stands on a line, this is line. Let's say this line name is line L. Okay. Now ray stands on a line. Now where is that ray? Let's say, students, that ray is this. This is the ray. Okay. This ray stands on line L, right? The sum of two adjacent angles so formed is 180. Now this is the axiom. Okay. We want to prove it. Axiom is a bit below the theorem. Theorem is proved by mathematical reasonings or mathematical deductions. But it's an axiom, it's supposed to be understood. So this is a ray standing on a line L. And what are the angles formed, students? This is angle 1. We have just explained before also. And this is angle 2. Now, students, we have already studied in the last lecture that how an angle is formed. An angle is basically formed by two rays, one ray and second ray. Right, students? Two rays, you know, starting from the same origin point, and that origin point, maybe let's say O. Two rays starting from same origin point end up forming an angle between them. Let's say that angle is theta. This theta can be 0 degree also. It can be a right angle, acute angle, or obtuse angle till infinity also. So, students, now what I want to say is that axiom says if a ray stands on a line, the sum of two adjacent angles so formed is 180. He says angle 1 plus angle 2 is equal to 180 degree. It's an axiom. It's an axiom. We need to understand. And what is the logic behind it? There may not be any mathematical proof of this. Maybe. Doesn't come to my mind. But there's definitely a mathematical reason behind this axiom. Axioms normally have reasons, very solid reasons, so they are universally acceptable. Now, students, you see, one angle has arms, let's say OA and OB, and angle 2 have arms OA and OC. Is it right? OA is the common arm. OA is common arm of these two angles. Now, the non-common arms, that is CO and OB, CO and OB are forming a straight line. In this case, the non-common arms are forming a straight line, and hence we can say the sum of angle 1 and angle 2 would be 180 degree. Students, do you see what is the relation between supplementary angles, adjacent angles, and linear pair of angles? These angles 1 and 2 are actually linear pair of angles. And you can also say sum of linear pair of angles is 180. Why? Because COB is a straight line. And this is a, what is this known as? It's a straight angle. Well, there's one more thing which can be added, straight angle. All these things, straight angle, linear pair of angles, adjacent angles, supplementary angles, here they are pointing towards a common thing. Angle 1 and angle 2 sum is 180, supplementary angles. They are also adjacent angles because their one arm is common. This is linear pair of angles. Linear pair of angles means it's a straight line. Ray is there on that. That is linear pair of angles, angle 1 and angle 2. And angle 1 plus angle 2, or you can say angle COB is a straight angle. Also, you can say it's a straight angle. Okay. See, students, we can state the reverse of this axiom also. What if the sum of two adjacent angles is 180? It's given here now. Angle 1 plus angle 2 is 180. Students, this is given. Then a ray stands on a line. Then a ray stands on a line. Oh, sometimes used, very much used. Again, the sum of two adjacent angles is 180. So what he wants to say is that, let's say this is the one angle. Let's say this is angle X. And there's another angle Y. And sum of these two angles given, angle X plus angle Y is 180. This is given. This is given. Then a ray stands on a line. And which is that ray? This is the ray. This is the ray which is standing on this line. You may name this line as L. This is a line. Hence proof. Let's go further, students. Okay. Now we have a theorem. Now when we talk about a theorem, students, you need to give a proof of this. When you go for a lemma or a postulate or an axiom, things are different. Okay. It's understood. No proof, it's understood. Yes, it applies to my conscious. It applies to everybody's conscious. But when you talk about theorem, you have to give a proof. He says, if two lines intersect each other, then the vertically opposite angles are equal. We all know it, they are equal, but we need to prove them. So this is one line, let's say, and let's say this is other line. Let's say this line name is L and this line name is M. Now this is two lines intersect each other. They are non-parallel lines. They are intersecting at a common point, and it has to be only one point, a distinct point O. You can name this point anything. Now these two angles are these two angles. This angle is equal to this. This angle is equal to this. Maybe you can say angle 1, angle 2, angle 3, angle 4. Now, students, we need to prove it. So, we will prove it using linear pair. What? This is a ray stands on a line, then the sum of two adjacent angles so formed is 180. Okay, this is also, you can say linear pair. You can also name it as linear pair axiom. So here we use this linear pair axiom, to prove this theorem. We're going to use this concept, a common understanding, to prove this theorem. See, if two lines intersect each other, these are intersecting, then the vertically opposite angles are equal. We all know they're equal. So, how? Now you take line M, or you can take line L also. If you take line M, you see students angle 3 plus angle 1, you know. So angle 3 plus 1, angle 1 are linear pair angles because they are on a straight line. We know that if it is a straight line, M, and you can say that this is the, I'm sorry, I draw one line parallel to this. Huh? So let's say this is a ray on this. So already we have studied this angle and this angle are known as linear pair angle, and linear pair, sum of linear pair are 180 degree. So this is equal to 180 degree. This is our equation 1. Similarly, students, you see L is a line on this line L, on this line L, this angle on this line L. L is a line on this line, angle 1 and angle 4 are also linear pair angles. Angle 1 plus angle 4 is also equal to 180 degree. This is my second. How?
Angle 2 4. Angle 4. Angle 2 plus angle